Okay, the next talk, it's about the domain map of Northwest Queensland. It's the combined talk between me and Dom. And so before we begin, I'll just like to acknowledge the authors, myself, Dom, and Leslie Culpepper. I'm going to shout out because he's a retired, sort of friend, but, he was so excited about this, a bit like me. He came back from his retirement and helped me with this. This talk is basically a continuation of the toolkit. In the toolkit, we mentioned about domains, the 4 domains, but we never give you a locality of where the domains are. And as a result of that, we try to, make up for that, by working overtime, on time, and sort of come up with this domain map. For this talk, I'll split it into 2 halves. I'll sort of, cover the first half, hopefully, in shorter time. And Dom will talk about how, he constructed the domain map. I'll talk about, the geochemical toolkit, which I'll try and cut it out. Depth to basement database itself, what's in the database, and the definition of domains and application, what sort of methods applies into what domain itself. This is just a background that, Mount Isa has been, explored for a long time. And when you come to the new economic mineral, it's different from the previous exploration, because previously copper, lead, zinc, gold, and silver makes up about 85% of the data collected, and very little effort is put into looking for the strategic or the new economic mineral. And therefore, I think we have to revisit a lot of these things, with a new eye, looking for new minerals itself. Well, as this statement is taken from the toolkit, that exploration success depends on using the right methods in the right geological setting, and therefore you have we need to know where the domain is. Another thing is this: there's a lot of archival data that you, as explorer, should use to de-risk. And I mentioned there's about 1 million data over there. There's already 78,000 boreholes, and in every borehole, there's plenty of data. If you look at the previous work, you find that this is for soil samples over the Northwest Queensland. You could see that majority of the work is done on the exposed part of the Mount Isa, and very little is done outside. For stream sediment, you see that a lot is done within, but there are sort of sites outside. It's questionable how useful is stream sediments undercover, for rocks undercover. And so you don't get much success with that. For rock chips, again, majority is within the Mount Isa itself, and this is for drill hole. What's worrying, or what's sort of unique about this is you find that the drilling or the exploration, it's very much central to certain corridors that's deemed or modeled to be more prospective, and a lot of rocks in between has never been looked at. What's encouraging is that in the last 30 years, there's a lot of work drilled in and around the Mount Isa block itself, which really gives us enough information to create this domain map, as well as enough information about exploration outside Mount Isa itself. Similar pattern with the mineral occurrence data. 97% of them occurs within the Mount Isa block, and there are very few outside. But the very few outside includes huge deposits like Kennington, Ernest Henry, etc., and plus the new Ernest Henry that I mentioned there. Well, the next thing you talk about is, there's a lot of work done, geophysics, drilling, etc. We know from all this that the Mount Isa does not stop at the boundary where the sediment is. It continues further north and south itself. And therefore, we should really look at, extending this greenfield area beyond the boundary of the Mount Isa. That's where the toolkit comes from. I'm just advertising what we've done there. That's the toolkit that we mentioned, and also before the toolkit, we have collaborated with Richard Lilly for the Undercover project to do a pioneering study to see how far chemical signals can get through, the cover sequences. And he's concluded that it could go as far as 125 meters in unconsolidated sediments itself. Well, next we talk about the database system. This is the headers for the database, and I think it's all there in public arena. You can download it. But the thing that I need to sort of, point out is that the depth of basement, it's a lot of interpretations that's been involved. Basically, we look at this from the top of Mesozoic, top of Paleozoic, and top of Proterozoic. For this depth of basement sort of work, we also include a lot of mapping data. This is useful for the Proterozoic or the outcropping areas, as well as the Mesozoic or the domain 4 area. All drill hole information are collected from company reports, from the reports you submitted to us. But there are problems with that, in the sense that a lot of the reports submitted are lithologic logs. It does not give us any indication where Proterozoic starts or where it ends, or where Mesozoic starts or where it ends. And so we need to go through and we need to recruit a lot of very experienced geologists. I could name, people like, Bill Perkins, Laurie Harton, Leslie Culpepper, and the rest, to help us to actually, to draw a line where Proterozoic start, so that we could sort of put that as a depth, of that depth to the Proterozoic itself. I've created a sort of descriptors, where we can describe different units in the actual report itself. And so if you're interested, to see what's in there, you could go there. So this database is appended to the report. It has about 63,000, sort of points to constrain the depth of basement itself. This is what the depth of basement itself. The 4 domains, the domain 1 is where you had outcropping rocks. Domain 2 is the unconsolidated 1 to 25, 3, 25 to, probably 125, because that's the limit that, Richard Lilly and Keith Hannon came up with. And the 4th one is the consolidated, rocks, under Paleozoic or Mesozoic rocks itself. Basically, domain 1 and 4 includes mapping. The rest are all drill hole data. And the last slide just tell you what method can be used in the different domains. There's a lot of crossover between these, like, if you use portable XRF, you could use it on the surface or in drill core in domain 4. And so that table just sums up, the uses of domain using the various sample types and the various sort of analytical type. I'll sort of pass it on to Dominic.
Okay, I'll just talk about the construction of the map, because initially we had the borehole database and Joe said, let's just grid the borehole database and that'll be enough, that'll be good enough. But it ended up not really respecting the geology as we knew it was in the subsurface. So for domain 1, which I think is just the domain 1 and 2 discriminate between outcropping geology and geology that's under up to 1 meter of cover. So instead of using just the outcropping geology, we just did use the DEM and did anything that's less than 1 degree slope is likely to be covered in sort of superficial sediments derived from those rocks. So that's how domain 1 and 2 were discriminated. And I think we just put the old outline around it as well because it made it neater. And so that's basically the old outline of the outcropping Mount Isa Inlier versus one that's just been discriminated using the DEM data. And I think it gives a better picture of where rocks are likely to outcrop, although it's still just an estimate. And then we had there's 63,000 boreholes in the database or something like that, but only 15,000 of them were managed to penetrate into basement. So in some areas, there was some big gaps in the data where we knew that, like, for example, in this belt through here, and we know the Georgina Basin's there, but we kept, if you just grid the data, it comes across as a 25-meter contour, so it's not accurately representing the geology. So we used the East Isa AEM and the Oz AEM from Geoscience Australia to constrain the geology and the depth of cover where we didn't have any points. So it's enabled us to draw a more accurate representation of the depth of cover. Those are the points that I picked out of the East Isa AEM. That's the Oz AEM stuff. We also, in some places where we didn't have good coverage, we compared it to the sea-based model that FrogTech generated so that we just have a better idea of what's going on. And this is where I promised to do a better job using the East Isa AEM inversion that we've had completed recently. So that's not going to talk about the technical details of it, but it does a much better job of penetrating through that, particularly the conductive cover in the east. So that will enable us to extend this map out a little bit, and probably with some of the MT inversion stuff that Janelle has done, particularly in the Isa extension, we can extend down to the southeast too. I think we'll probably update this for the regional prospectivity thing, but yeah, it's the state that it's currently in. And that's all we've got for that one. Any questions? All right, yeah, well,
We got one question there.
Just a question. If you look how around Duga River, where you have the Landsborough graben, how the depth to cover changes suddenly, you have this type of patterns. I wonder if you can see on any of similar type of patterns around the exposed area. So, there will be, rather than uniform 100-meter depth, you'll have, here you have 100 meter, then you suddenly go to 500 meter, then you go to something like this.
yeah, you do drop off a cliff in a lot of places, particularly as you go out to the east.
To the south as well.
Could you capture that in your model, or
With the AEM, the trouble is you can't see the bottom. So when you have no more signal at about 150 meters, but then that's it.
Okay, thank you.